Gradeup, which is the largest online education platform for GATE computer science as well as all engineering students. Yes, myself Mallesham Devasane. Here I'm taking the 7th lecture on the upcoming exams where you might be preparing for IIIT Hyderabad or ISRO, BARC or any other exam that you might face in future after the GATE exam. Yes, you might be preparing for even written test or interview for Btech admissions. Yes, this course, these classes are going to help you. Yes, in case if you are watching this video, please don't forget to like the session and share with your friends and subscribe to this channel. Yes, the session is on practice on digital logic. So this session is going to help you to have a quick revision. If you are really facing ISRO exam or BARC exam, definitely going to help you, where you will have a lot of questions on digital logic if you are going to face ISRO exam or BARC exam. So remember this point, that digital logic has a good weightage in ISRO computer science. Okay. In case if you are new to this channel, let me help you. Let me introduce myself, that I have completed Btech from IIT Bombay and guided more than 1 lakh students in the past 12 years, and I have selected for various jobs, and this class will really help you how to face coming up written exams. And in case if you are not aware of the discount coupon code which is going on, this is the last day for availing the benefit. There is 30% flat plus extra 40% on that, and use code SAVER. SAVER is the code to avail the discount on a Gradeup Super subscription, guys. Alright, so this is the last day to avail the benefit. In case if you have any doubt, please call to this customer care 96500529904, and we are happy to help you all the time. Yes, in case if you are watching this video, please like the session, guys. Yeah. Alright. So let's start this session. If you're watching the recorded video, then please try to comment while watching the video. Yes, this is the first question on digital logic, and you have given, this was asked in ISRO 2018, and they have given 3 gates, 3 logic gates, and of course including the inverter 4 logic gates, and they were asking about the glitch, the duration of the glitch in this circuit. Yes, good evening Bartendu. You and me only are there in this class. What happened to other guys? Are they sleeping, guys? Are they sleeping? Okay. Alright. So what is a glitch? And when I look at this question first time, what is the glitch? And it's basically a delay to produce an output after giving an input, guys. They have given delay for each logic gate, inverter, NOT gate, that is AND gate, which is label 1 and 2. So total 3 gates. Here you have 3 types of gates: inverter, 2 AND gates and 1 OR gate. 3 types of gates. Yes, for the self-study, it is really important, as you are not aware how to complete the syllabus, so textbooks will help you. Gaming. If you have joined any coaching institute in online or offline, basically you can follow their notes class. Yes, it is very important, as you don't understand other people's notes, so textbooks is only the main, and you might be watching the videos, so when you don't understand, the textbooks will help you. 9 is for inverter and 10 for 1 and 2, 12 nanoseconds. What is that? 12 nanoseconds, guys. Anybody guys? What is this 12 nanoseconds? 2, and these are the 3 delays are given. Now the question is about what is a glitch you get if you give these 3 delays and to get the output. Let's see who will answer that. Hattie, what are you asking? A reference book is not a 1. 12, more than 100 books are there, reference books, Hattie. There is no particular gate book. That is a problem. People don't, people have less success rate with the textbooks. I am the one where I had also faced gate with the textbooks only. So I have also prepared self, but I prepared nearly 20 textbooks nearly. Anyhow, they have not given the delay for OR, but you can predict the input, these 2 inputs, when will be given to this OR gate. You can see that this side 10 plus 9. 9 is delay produced by inverter and 10 by this one. So to receive here 9 you have 10, 9 plus 10, here 19, and this one is a 12. So if you look at, this is going to give a 12 delay and this is going to give 19 delay. So to receive here there is a glitch here, plus 7. Plus 7 you have to wait. Total delay, if you look at, to produce an output, you need 7. The 7 is the delay that you need to wait to produce the output. The 7 nanoseconds. So in terms everything is given as a nanoseconds. Alright, there's no problem with that. So it's a very easy question. Just you need to understand how much a duration is required to produce the output while you are balancing the delays. Okay. Next one. What is the minimum number of, this is also ISRO question and very easy. Hardly it can be answered within a minute. Mathematics, you need to study 2 different textbooks. Gaming. Engineering mathematics, you might prefer any standard engineering mathematics. Mostly you can prefer Gravel for mathematics, and discrete mathematics you can go for Rosen, that's fine. Minimum number of 2 input NAND gates. Minimum number of 2 input NAND gates. What is OR gate guys? A plus B. How many of you know that is A plus B? De Morgan's law. You can apply bar twice to get A bar dot B bar and bar. So if you use this logic, for A bar you can use 1 NAND gate, and B bar you can use 1 more NAND gate, and A bar dot B bar, and this produces exactly what you need. So this is A bar, B bar and dot bar. Look at exactly this output is same as A plus B. So you require 3. But it is not possible if you do not practice such questions and concepts early before the exam. In the exam you might not get this idea, okay, A plus B I need to apply De Morgan's law, but this kind of practice you should need it. You should have already practiced it. If it is AND gate, how many NAND gates required? If it is OR, if you want to implement OR logic or OR gate, how many NAND gates required? Yeah. A very easy question might be. A very famous question to number system. If you have any number system, how to convert into other number system? This is octal and there are 3 options for hexa and other one is decimal. A decimal is slightly easy and hexa is also, because of it is octal, it is also easy. Here whatever the options they have given, all are easy options. But if they ask a binary, then you should do something different. Okay, that's also easy. Binary, yes. Binary, hexadecimal, these three are easy because directly you can convert to binary. 1217, it is already octal, so you can convert to binary directly. Binary is not a problem. Yeah, every octal digit you will have a 3 bits. So this is a 111. This one again 3 bits, 001, again 3 bits, 010, and this one will have 001. Now this is in binary, and to convert into hexa, because there are 3 options are there for hexa, so we'll try first hexa. Then 4 bits we need to collect. This one will give you F, this one will give you 8, yes, this one will give you 2. So 2, 8, F, exactly matching with that. So you can choose B. Yeah, it is also easy. It is also easy. Yeah. Yeah. How many of you heard about dynamic hazards in digital logic? Will it happen only in combinational or will it happen in only in sequential? The dynamic hazards, yeah, delay in producing the output or whatever it is. Yogesh, what is a group 4? Acha, okay, the digits, previous question, okay, all right. Is theoretical question. These hazards will produce some kind of glitch or delay in the circuits to see the proper output. This could happen in registers or this could happen to the combinational circuit. Just now we have seen a glitch. Yes, that kind of hazards, dynamic hazards can happen in any of the circuits, both A and B. It's both A and B, guys. It can happen. Dynamic hazard problem occurs in both of them. That's fine. That's fine. Don't worry about it much. When you are studying the theoretical concept, you will understand much. It's both one word. It's not only registers. It also happens in combinational circuits too. Let's look at ISRO 2016 question, which was so easy to answer. And how many of you know the 2's complement other than the 1's complement plus 1? Don't do don't do 1's complement 1, guys. It will take time. Just search for the one in of 1 from right. It will change the number. After this, do the 1's complement. It will change the number. But this one, after 1, no 1. So 2's complement, you will get the same. And but after this, you need to do 1's complement. So this number is going to change. Only C is not going to change. Because how many of you know 1,000,000? If you do 1's complement plus 1, you will get same. 1's complement is 0,111 plus 1, you will get again same. 1,000,000. 1,000,000. Come on, 1,001. Why? Why people are answering 1,001? What are you doing? Gaming, Bhartendu. Why are you doing that? Alright. Very easy question, right? Very easy question. It was very easy question, yaar. This is what in ISRO happens. They don't ask much difficulty, but once in a while it happens. Let's see who will answer this question. See how easy the digital questions were. 90% of digital questions in ISRO and TAFR are really easy. How many minimum number of NAND gates required to implement this Boolean expression or Boolean function? How many minimum number of NAND gates required to implement this function? Let's see how quickly you can answer it. And remember, expect either it takes seconds or minute. Do not assume it is a very big problem. It's a very easy problem. Yeah, good. Yeah, Sunita, right. How easy it is, guys. Just A, take the common. You got 1 plus B bar plus B bar C over A. For this you don't need any gate. You don't need any gate. A is just 0. It's just 0, guys. Yeah, you don't need any NAND gate for that. Because directly line available you can take without any gate. Yeah, this is what ISRO questions about. Most of the questions are looks really easy. What's happened? Wait, guys. Why it is not responding here? Okay. ISRO 2014, which was I think similar to the previous one. First problem we have solved. The same kind of glitch question. Yes, this is also duration of glitch for Q. And they have given for everything. Inverter and or everything is given. A similar question, guys. 2 times it was asked. That means high probability to ask again. Inverter. Look at the delay. And or 6, 10, 11. They have delay 6, 10 and 11. So 6, 10 and 11. Maximum easy giving. 80% of ISRO questions are really easy giving and 20% will waste your time. In GATE it is opposite. In GATE the 20 to 30 questions will be easy and most of the time you need to interpret properly. And ISRO it is easy because of you need to solve many questions in less time. And this takes is 16 nanoseconds, let's say, and this is 11 nanoseconds. So to get the proper output, you need to wait here 5 seconds. 5 seconds you need to wait to see the proper output. So total you have a glitch 5 nanoseconds. Why 27? What did you do? You added everything. These are the parallel inputs, right? Why do you need to add? No, we don't add this too. These both are different inputs. These both are different inputs. They're not coming in the same line. Giving that is you should not do. You should do something like this. When will you add? If you have something like this and you have something R, then you can do that. Then you can do that. Whatever it is, doesn't matter. Now then you will add 6, 10, 11. Then to see the proper output, you have to wait. Now you will add it. 6 plus 10 plus 11. This is different. This is 27 delay. This is not 27 delay. This is only 5. You need to wait for 5 nanoseconds to reach that 16, to reach that input, to reach this input. Yeah, exactly. If you don't wait that 5 nanoseconds, you can't see the output properly. Yes. It's not a stable basically. It will be stable if you wait that 5 nanoseconds. Correct. that output we don't care. We know that delay is there, so we are going to wait 5 nanosecond. Next ISRO 2014 question. And please like the session, guys. Those people who are watching this video, don't forget to like the session, guys. Okay, gaming, it happens. Okay, it might take time where you need to apply that outputs of one gate to input of other gate, so it might take time. So this question slightly takes time, slightly, compared to the previous questions. Any answer so far? Yeah, no answer set. Let's see who will answer first. You can just do it very quickly. This is a DC bar, and here just B comes. Here AB bar, NAND gate, and here DC bar B, DC bar dot B bar, and now this is, you need to apply again NAND gate. Apply it, guys. DC bar dot B bar as one input, other input is, let's apply like this, AB bar, and NAND you need to apply. Yes, you need to simplify, that's all. You need to simplify. See, you got an answer. Let's simplify this, guys. You know, bar, when you apply to this both, what do you get? DC bar dot B, and this bar gets cancelled, plus you get, and AB bar, that is also going to cancel bar. Just once you apply bar both sides, now you have here, this is a DC bar is nothing but D bar plus C bar, and dot B plus AB. Now you can see that this is a BD bar plus BC bar plus AB. Which one is matching, guys? BD bar, BC bar, AB. Yes, C is matching. Yes, it may take time, but if you do slowly, one after other, you will get an answer here. And maximum time, don't assume that you can't do it. You can easily do it, only you should move further. Alright. Good. Okay, those people who are not aware of the batch, weekend batch is started, guys. Only 2 days happened, and the enrollment is already started, and the class is already started. But this March 13 batch, just enrollment started. The classes are going to begin from next week. So be ready for this batch. Whoever want to prepare for GATE 2022, there are 2 batches which are happening right now, and the enrollment already started for both. And in case if you want to join weekend batch, and this is Excel batch, you should consider. And if you want to join a Vision batch, then or regular batch, consider Vision batch. And maybe you can attend both the classes if you are having that much time. Okay, 9650052904. This is a helpline number which will help you to get the subscription. Yes. Next question is how to convert given decimal number to binary. Yeah. Very easy question again. We've seen how much time it takes, hardly 1 minute. 40 to convert into binary, 0.75 convert into binary. 0.75, how many of you know it is same as 1 by 2 plus 1 by 4? Like this is a 0.5, this is a 0.25. If you add them, you will get 0.75. And 42, look at the nearest to 2 power. Look at the nearest 2 power. 2 power 5, 32, 2 power 6, 64. So you need 32. So 10 left. 10 means 8 plus 2. Only this powers you need to add. 2 power 5 plus 2 power 3 plus 2 power 1. Only this 3 you need to make a 1. So who is that? 2 power 1 and 2, 3, 4, 5. 1 and another one is 110, that is going to match this one 110. So you are going to choose 101010.110. Yeah, option A is the right answer. The option A and C both are same. The left side before the decimal point, but after decimal point they have a difference. Yeah, good. Okay, another one. Let's see. It's theoretically very easy questions, guys. Theoretically very easy questions, and in fact this digital logic questions are going to give you good marks in ISRO exam. If those people who are preparing for ISRO, and remember digital logic can save your time too, because they don't take much time to answer in the exam. 3-stage counter using flip-flops, and what will be the value of the counter after giving 9 pulses to its input? But the question is, initially the pulse is initially the counter is 1. Initially the counter value is 1, and you have 3 stage. You have 3 stage flip-flops. That's a counter. Then what is the counting sequence? What is the counting sequence, guys? It will start from 00 to 111. So the counting sequence is total how many, guys? Total how many? Total 8 numbers are there, 8 values. But it's already told that initially it's 1. Initially it's 1. Initially it's 1. After 9 pulses, where do you come here? How many of you know after 8 pulses you will get to the same count? Then who is the next one? 0, 1, 0. So this is after 9 pulses. So you will get back to the same count after 9, after 8 pulses. And just one more, 9th one, you will get 0, 1, 0. That is 2. That is 2. Like 1, 2, 3, 4, 5, 6, 7. Then it comes to 0 and to 1. So you started here, and after 8 will come. This is the 9th one, and also first one. After 9th pulse, we will get the 2. So 2 is an answer. Sunita, why 1? 1 is for 8. They asked 9, right? 9 pulses. If you do 8 pulses, we will get to the same one. Initially, the value starting from 1, not from 0. If the value starting from 0, then it is 1. If the value starting from 0, then 0 to 0 after 8, and 9th pulse will go to 1. But initially they have mentioned, assume that the value of the counter before giving any pulse is 1. They have already given it. Everybody got it? This is the initial now. Right. Almost everybody did the mistake. It's not A, it's a, yeah, small mistake can cost. It's very easy, but you should not ignore this one. The counting, the value counter begins from 1 here. Alright. Next one, the output expression of the following gate network. I think so far this is only the subject we are doing very quickly than any other subject so far. But really digital logic is not easy for me when I was studying Btech. Very simple, very simple. Just you need to look at the circuit and just apply it. Don't assume it's an electrical circuit. This is X bar, and this comes here Y bar. It's AND gate, so XY, and this AND X bar Y bar, or Y bar X bar, doesn't matter. Or so just you will get XY plus X bar Y bar. That's all you have to choose. Right? any of B and C look same. I'm just changing it, to avoid confusion. Yeah, because B and C look same, xy plus xy is again xy. Yeah, you need to choose A. In ISRO 2011, look at guys, how easy this question is. You can apply distribution or you can apply x plus y, x plus z. If you have not remembered any laws, simply you can apply where is right xx, xz, you'll get x plus xz, right? Then you can apply yx plus yz. So if you take x common here, if you take even x you can take common here up to here. So x1 plus z plus y plus yz. So here this is going to be 1. So x plus yz. So very simple. It's a very simple. Directly you get x plus yz. So easy. Okay. Good evening, Nagendra. This time, yeah, many times you might be, seen this kind of equation, just like x exclusive or y and exclusive or y. Here parenthesis doesn't matter. As you know, most of you, it's satisfies associative. It satisfies associative. You can also write if you want it. You can also write if you want it x exclusive or y exclusive or y2. It also you can write. If you write this, answer is very quick. If you don't do this, guys, you need to simplify, you need to apply the laws, it will take a lot of time. But if you do this, answer is within seconds. Those people who know about associative law, then this one can be written as this. This is left associative, this is right associative. Both are true for exclusive or, both are same for exclusive or, because it's holds. So now you can do the something, you can do the something. You can do something now. Already started the classes for GATE 2022. Y exclusive or Y? How many of you know it is 0? Because you will get 0 exclusive or 0 or 1 exclusive or 1. Both are 0 only. And X exclusive or 0. If X is 0, the answer will become 0. If X is 1, answer is 1. That means it purely depends on X. So answer is X. Yeah. So this method is going to take less time compared to the, many people might do these things, but do avoid such things, guys. In the exam, they might cost your time too. Here, writing x bar y plus xy bar. You know what is the difficulty of this equation? Which is easy method, guys? Which is easy method? Obviously, I don't like this method at all. Y bar plus and this bar y. And have you seen, if you miss one bar writing somewhere, then it is going to cost you. And you need to substitute, and which will take a lot of time. Yes or no? Yeah, this is not recommendable if you know that technique. Of course, if you don't have this, you have to. Okay. Consider the following Boolean function of 4 variables. It's independent of how many variables? Let's see who will answer this. Try to have a simplified one. You can answer it. How many variables are it is independent? Will it depend on every variable or independent of any number of any variable? For this you require K-map, which will give you very quickly. This is a 9, 11. This is a 9, 11. Let's see, first we will answer it. Then I will explain slowly how to do that. Write the function. Saujanya, write the function and find out how many variables it is dependent or independent, because the questions are two. Independent of how many variables? Do you require xyz to show the function of this terms? Suppose if you get to know, suppose f is equal to 1, the result is, that means f is equal to, the sum is 1, it means true. F is false, then you don't need any variable. You don't need any variable. But find out what is the answer. F turns out what? B. So people got independent of two variables. How is that possible? First you should draw, or you should write the terms, min terms, then you should simplify. And use the technique one way, WXYZ. How many of you know? Look at how do we draw. Quickly we can represent this. This is W and this is X, this is Y and this is Z. It's a very easy technique, guys. It's a very easy technique. Once you start practicing it, you can always stick to this. 0, 1, 2, 3 and 4, 5, 6, 7. No need to write 0, 0, 0, 1, all these things. 8, 9, 10, 11, 12, 13, 14, 15. Once you have this, now you can start representing the ones. The 1 is given, so you write a 1 here, and 3 is given, and 4 is given, 6 is given, and 9 is given, 11 is given, and 12 is given, and 14. So if you look at this, you can represent these 4 ones as a quad. Then you will get a Z bar, and this is there in the X. So you will get the term as this quad as X and Z bar. Another one, this 4 ones as a quad, so that represent within the Z, but that is within the W bar, within the within the X bar. It's a W is the whole thing, right? Yeah. Write it. For this, you can represent as Z and X bar. So X bar Z. So W and Y not required to represent this function. So it's independent of two variables, or you can say dependent of two variables. Both are right answers. Independent of two variables, or you can say dependent of two variables. Both are same answers. Because total 4 variables, if it is dependent on two variables, definitely independent of two variables. Yeah. Both of them are correct. Even this is also correct. Yeah. A very easy, straightforward question, guys. Yeah, Yogesh. It is exclusive OR function. And most of the computer science students, they don't practice digital logic. As you know, you might feel it is an electronics people subject. How to write expression, not practiced, not practiced. How many of you are not aware of this, guys? Look at this mapping. Look at this. First, if you can't remember this, it's a very easy to do that. It's a very easy to do that. I told this is a W, X and Y and Z. Those people who are very new, just look at what I am doing, guys. This is a W and this is a Z and this is X and this two columns is Y. Now it's very easy to represent. As you see that 1, 1, 1, 1. Now look at these 4 ones are common to which variable? Yes, in this representation only I am talking about 4 ones. Look at these 4 ones common to which variable? 4 ones are there within the Z, but 4 ones are not there within the Y. Half of them are there in Y, half of them are in Y bar. So when half of them are there, we don't consider ever. All the 4 ones are there in the Z and all the 4 ones are there in X bar. If this is X, outside is X bar. Do not forget, we are writing only the variable, but there is another one, the complement of it. So 2 things are there. If this is Z, outside is Z bar. If this is W, this is W bar. If this is X, outside is X bar. If this is Y, this side is Y bar. Now your job is to look at all these ones are present in which variable. So first thing is they are present in Z. And also look at these 2 ones and these 2 ones. Both are present in even X bar. So we say that it is X bar and Z. One. Other one, look at these 4 ones. These 4 ones. You know that this is, you need to represent. Look at this one. In this side, Z bar is a common. And look at this one. X is a common. So X, X and Z bar. So we say X Z bar. Yeah, this is how we represent. But behind that, you have a reason. We are not doing just blindly. Why we are writing W? Because this is 0, 0, 0, 1, 1, 0, 1, 1. So W term is a 1 here. W term is a 1. That is why we are representing it. That is why we are representing it. Alright, alright. Clear everyone, guys? Okay, not this. This is a 1, 0. This is a 1, 1. Sorry, guys. 0, 0, 0, 1, 1, 0, 1, 1. Yes. Yeah, I hope. Now, teaching digital logic in a few minutes is very difficult, but understand the representation. If you are following any other representation, you must be careful. There are various representation, guys. I have taken W, X, Y, Z. You can take reverse way also. W, X, Y, Z. But this is slightly confused one. WX you are writing this side, YZ you are writing this side. So you need to change your representation. But this is straightforward. This is very easy. Alright. A Boolean function obtained by adding an inverter to each and every input of AND gate. This is the AND gate. How many of you know if you are adding the inverter to each input, what happens? That is going to be a bubbled AND gate. How many of you know bubble AND gate is equal to? Bubble AND gate is equal to. If you are confused, just take an input. If this is A, B, you get A bar, B bar, A bar dot B bar. What is this A bar dot B bar, guys? Which complement it is? A plus B bar. What is that A plus B bar? Is it A bar dot B bar? What is the bubble AND gate? It's not a NAND gate, remember. It's a bubbled AND gate is equal to NOR gate. NOR gate. You can also write as the same gate. Equivalent representation is NOR. Yes, NOR, not a NAND, Sasikala. It's a NOR. Bubbled OR. What is the bubbled OR, guys? bubbled R. What is the bubbled R? This is x bar plus y bar. What is this x bar plus y bar? Is same as x y bar. This is the NAND. This is the NAND. So you can write as this is a NAND. So bubbled R is the NAND and bubbled AND is the NOR. Yeah. So this side is different. In future you may predict this kind of question also. Very interesting TIFR question, guys. Very interesting TIFR question, guys. You can debate this question if you want it. Assume only one option is right. Don't assume more than one option is right. Which one you choose? A variable that takes 13 possible values can be communicated using how many bits? And those people who are watching this video, if you have not liked the session, guys, please like the session and also share with your friends. This is what Batindu. That's why I said you can debate this question. That's what I'm talking about. You got the concept. You got the concept. Look at variable that takes 13 possible values can be communicated using, yes. This is not going to represent a bit, it's 3 point something, but this many bits definitely required. D is answer. That 3 point something is not the bits, and you already have the option 4. You have to go for the 4. So sometimes if you don't have this 4, yes, theoretically you can choose that 3 point something, you have to write a seal something like this. This is the right answer. But they have not given that, right? How do you know that it is seal or floor? Right? That's not, you are not going to choose that formula. If they give this, yes, this is also right. Everybody, 3 point something you will get, then that will become 4. Either this one or this one. Already 4 is there, then this is only 4, nothing but this is only 4. So you can't choose a C here. You should know that. You should know that. It is not a C programming to choose a, C programming, even if you take the C programming, it chooses the floor values most of the time. If you do the typecasting to the integer. Alright. I hope this session might help you, because I have another session, guys. I just want to help you. If you are learning something from this, please don't forget to like the session and also keep attending the coming session and also other faculty sessions. And we are here to help you to get success in other exams that you are going to face. And thank you so much for joining today's session. And please don't forget to call our customer care if you want to take the Gradeup Super subscription, as today is the last day to avail the discount. And you can enroll for the 2 batches which are going on right now, that is the weekend batch and regular batch. And regular batch, the classes will begin soon, but weekend batch just 2 days completed, yesterday and day before yesterday, Saturday and Sunday. And this is the offer code SAVER to get an access to all the live courses as well as including mock tests. This is the last day discount that you have, SAVER 30% off plus 40% off additionally. Yes, if you are enjoying Gradeup channel, please go to the Play Store. If you are not installed the Gradeup app, yes, please go to the Play Store and install the Gradeup app and start preparing from today. And you will have daily quizzes posted, and keep attending all free live classes to get to know what we are teaching on Gradeup. Yes, thank you so much for joining today's session. See you, take care, and all the best for upcoming exams, guys.